Hello, everyone, and welcome to the show. I'm your host, Kaival Yapte, and this is the Geek Narrator podcast. In this podcast, I talk about technology, I talk about distributed systems, I talk about general software engineering, and I sometimes talk about very general practices and experiences. So, today's episode is something like that. So, we are going to talk about system design specifically for senior engineers, and I am joined today by Gaurav Sain from Interview Ready. And he has vast experience in teaching system design, the concepts involved. He also runs a YouTube channel called GKCS, as you can see at the back. And so, yeah, we are going to talk about system design, everything around that. We are going to share our experiences. And I'm really excited to have you, Gaurav. So, welcome. And let's start with a little bit of introduction about yourself, about Interview Ready, and about your past
Sure.
experience.
Sure. Thanks for that, Kavya. Thanks for inviting me. I've been watching your podcasts, especially on Cassandra and other engineering systems. It's amazing. I have to say that the depth is unparalleled, or maybe it's difficult to find this kind of depth. Yes. So thank you for that.
Thanks.
The About me, I'm Gaurav. I have a YouTube channel, like Cavalier said. It's largely on system design. Most of the content is around system design. Earlier, I used to do some corporate programming, and now I work on a company called Interview Ready, which helps software engineers prepare for their technical interviews. And at this point in time, we have two courses. One is on system design and behavioral, and at the same time, we are thinking about how we can bring in a practice platform or discussion tabs. But yeah, that's what I'm working at.
Yeah, sounds perfect. And I would like to start with setting up some context here because the topic can sound a little bit confusing. We say system design for senior engineers. So just to put out some disclaimers here, system design stays the same, right? It's not going to change depending on your experience. If you're an architect, if you're a junior engineer, fresher, or whatever, it's just the expectations and the scope that changes depending on what system you're working on. So it's just going to be like some guidelines, some experience sharing, some thoughts on how a system design can be approached when you're a senior engineer as compared to a junior engineer. Now, there's also this thing like junior and senior. It typically depends on the years of experience and the quality of experience you have. Let's say you have 10 years of experience, but you haven't really designed a system. You might still be a junior in terms of designing a system, right? But you might be a senior
Yeah,
engineer at your company. So that is all
yeah.
contextual. But here, what we mean by junior and senior is probably based on years of experience in designing systems at your company. And that's my thoughts on that. So, Gaurav, if you want to add
Yeah.
something there, please feel free to do that.
Kevali, I think you summarized it really well. One of the things is years of experience is a good indicator. At the same time, the kind of responsibility that you have in your current team really defines a lot about whether you are performing as a senior or a junior engineer. A senior engineer is not only expected to get things done, they're expected to design in a way that is extensible and that is true to the product. So if you go to a young engineer who's still gathering themselves and looking at the tech side more than the product side, they will be thinking about how do I write this code or how do I make sure that it is correct. While a senior engineer usually also looks into what is the intent of this kind of a system. And
Yeah.
if they have to bring in extensibility, but they cannot make a system fully extensible because that is not true. It's not possible. So what they do is they look at certain parts of the system which are expected to be changing. You're right, absolutely right. The way in which they design the system changes, the system doesn't change. Or it's not like the product manager will be super easy on you if you're a young engineer. They're just going to give you a much more narrowed down task. While for a senior, there's an expectation that you will understand.
That makes sense. And so yeah, like setting up the context just because it might be confusing that hey, if I'm a senior engineer, should I use some different practices to design a system? No, the fundamentals are going to be the same.
Yeah,
The
yeah,
best practices are going to be the same, and it's just about the scope you're handling, the expectations you're trying to match, and all that. Great. So let's try to set up the foundation knowledge that is required for system design. I see, so when I see the trend that goes in today's world, right? So there are system design in two classes. So one, people do system design for interviews, which is very important, and it has very narrow scope, right? But then
yeah,
there's a very
absolutely.
wide variety of system designs and vast scope that comes in the real world where you're working at a system. There's customers' money, there's business revenue, there's product deadlines, and all that. And that changes the entire scope. So, what we are going to primarily focus is on the real world part, but of course, it also tries to match the interview expectation, because as a senior engineer, if you're interviewing for a company, your expectation might also change. So try to apply that knowledge in both directions, but it's mainly on
Yeah.
the real world side of the business. Great. So let's talk about the foundational knowledge that is a must have. Again, must have is asterisk because it depends on the type of system you're designing. But let's say the basic fundamentals that you should be focusing on. What are these?
Okay. Well, some things that you should be quite good at, I would say, is if you're going for an engineering manager position or a person who is expected to design the system without knowing the internals, then you are mainly expected to know how these components interact. So let me take an example. Let's say you're a senior engineer and you are expected to design a system. The way in which you'll design a system will be around some of the implementation details will seep into the design. While if you're looking at engineering managers or people at a slightly higher level, then they will not get into the details. So what I have done right now is I've taken the senior position also and kind of split it into different areas. Yeah, software engineering is really large. Let's just focus on the senior engineer part. There's an expectation that whenever you're designing a system, you understand its ins and outs. And there is also an expectation that you understand the kind of people who will be interacting with the system. There are people who will be using the system as a black box. There's going to be certain API calls that you're going to be allowing inside the system. At the same time, you have maybe some data sources from which you're picking up data or certain services you're interacting with. What happens then is the first thing you do is you set boundaries. So this is the task I have. These are the requirements. How do I set up a boundary so that everything which talks to me gets responses back, and whoever I need to talk to, I can get responses from them. So this is
Yeah.
pretty much setting up the service boundary. And then you say that, all right, if this is going to happen, then what kind of data do I need to store? You're already starting to look at technologies like, okay, am I going to store the data in this way? If I am, then should I use a NoSQL database? If I'm going to be processing this data in this way, how much time will I take to process it? Should I give it in real time? Should I give it as an email? If you have a reporting system, maybe setting up an email or setting up a dashboard is good enough. Depending on your requirements, the most important thing though is that you are basically like a person. If you think of your service as a person, then what are the things that you are capable of and what do you need to do to be capable of the API interactions? That would be the starting point for, and usually senior engineers pick this up because the thing about, let's say, a person who's young and who's, let's say, not very experienced with system design, what they are expected to do is you're expected to add a feature. Sometimes you're expected to fix a bug, enhance a feature, but adding a feature is something that up to SD2 is totally fine. If you're talking about building a system from scratch, there is an expectation that there are many decisions to be made, all of them having significant potential long-term impact. So this is how you start.
Yeah, I think that makes sense. And it's again, as you mentioned, it's mainly on the scope, right? You might be asked to design like a very small feature of a bigger system, or you might be asked to design the bigger system, but still, which is a subcomponent of some other bigger system, right? So it's always one level that you have to try to step up and see from a bigger picture, like how these interactions are looking. And one
Yeah.
good point that you mentioned is about the users of the system, right? So there can be like external customers, there can be internal customers, there can be developers who want to also do something with the product, right? So once you design a system, it's not just about exposing it to the external customers, they are using it, it's fine. It's also about how you are able to quickly identify issues. You are dealing with a system, right? So monitoring and all those things also come into the picture. So as we
Yes.
said in the beginning, the scope will slightly widen when you grow up the ladder, but the fundamentals are going to be the same. And the steps that you mentioned, designing or defining the boundaries of your system, and that's a good place to start because that's when you identify some of the use cases, how the communication is happening. And when you're clear on that part, designing or deciding what technology to use and what options do I have. I've seen in typically in companies, they have a tech stack, right? So you don't really have
Yeah,
a ton of
exactly.
choices.
Exactly.
So if they have a MySQL cluster, right? So you can't just say, oh, I know Postgres, so I'm going to use Postgres, right? So that's not how it is going to work. But the
Exactly.
technology choices, as in identifying what could be the right model to apply and not a specific implementation, like relational NoSQL database or using a queue, or I'm just giving some examples. So I think at a
Yeah.
broader term, understanding the abstractions and the high level idea of the system is important. And then technology implementation detail would depend a lot on what kind of company you're working at.
Yeah, Kelly, I totally agree with you. In fact, the point that you made about the tech stack is so important because it's not necessary that you're going to get to decide everything. Like the language that you're going to code in is probably already decided. There's going to be a tech stack which is offered to you, and it has a wide range of solutions, and you're now going to use that tech stack. It's not like you're going to have your own network protocol.
Yeah.
More often than not, you're just going to use the thing that is in the system. Even if you're creating an entirely new feature for, that's when yes, you can talk about, oh, I need some specific solution. But otherwise, no. Even in startups, which are super flexible, there is
Yeah.
the idea that once this engineer leaves, how much debt can you acquire? So there's going to be some discipline, some standardization. So I think that's a good point. Yeah.
Yeah, that makes sense. With this, I want to share one example of my own, like what mistake I did, right? So I was asked to design a system which would do something periodically, not exactly periodically, but on a certain event, you would do something, right? So let's say you do something XYZ. And I was driven by learning opportunity. Oh, this is a learning opportunity. I want to do something new, right? So I was
Yeah.
exploring, and also my manager asked me to do that. And I explored and say, oh, you know what? AWS Lambda is the way to go. And I did not really, I thought it from how it would work using AWS Lambda, but I did not think if there are a cheaper solution that already exist in the system, that already exist in the company. I did not think about that. And then I went ahead, I presented to the wider group of audience. And then the director of engineering asked me, like, okay, this is cool. AWS Lambda is great. But have you really looked at that we have a Jenkins cluster and that can just check out periodically? Because this is not an event that is very frequent, or you don't need that. It can just check if it's happening, it will send. Sometimes it's okay if it doesn't get any event or whatever. But the idea I'm trying to put here is that as an engineer, I was putting my personal aspirations and the learning thing in front of the goal that I want to achieve, which was good in a learning way, but it's not really practical. As a senior engineer, I could have looked at what existing things I have instead of reinventing the wheel or necessarily bringing some new tech stack. I could have looked at the existing story, existing stuff that I have. And then it was a simple solution. We just onboarded onto a Jenkins cluster. It was implemented. And the idea of using AWS Lambda was gone. So the point is, it's not to compare AWS Lambda or the other approach. It's to be realistic. Like at the end, you're working for a business that wants to generate some revenue, that wants to do things quickly, and it's good to work or try out new technologies, but it's not always practical. So as a senior engineer, I think that understanding the current tech stack, the current limitations, and the trade-offs that your tech stack is bringing along is very important, and not just, oh, this is not going to work, let me try something new. So what are your thoughts on that?
Yeah. Yeah, no, Kevali, I think you have made such important points, especially when it comes to startups. At least I can vouch for this. AWS Lambda is exactly what we implemented for. We have a learning management system at Interview Ready for the video lessons, and there's a quiz also. So the expectation was that, oh, video lessons and quiz are different. So why don't we create a microservice? Oh, no, we shouldn't create a microservice. Let's create an AWS Lambda function, which will be called whenever a CSV file is uploaded and converted into quiz. The basic idea is that you have some sort of a file which is going to be converted into a quiz question.
Mhm.
Now, I, of course, found this to be a brilliant idea because I had been drawing white boxes all my life on boards. But when it came to reality, it is a needless isolation of concerns. You are actually not isolating concerns, you are isolating your business requirements now. It's the same thing, it's just a content piece, right? And I had a person who was supposed to be very good at tech, and I was supposed to be good at tech. And we both failed to catch as a needless complexity apart from the
Yeah.
cost. Uh, Now, what happened is it was written in TypeScript. We have our server, our main server in Golang. We had to migrate that. It had its own database. We had to migrate that. And these mistakes cost. They cost in terms of time, which is basically opportunity for a startup.
Yeah.
They cost in terms of money. Our AWS bill used to be 1.3 lakh per month.
Mhm.
And for a startup, it's significant. Now it's come down to roughly 30,000. So there are many reasons for that. I can go on about the stupid decisions I have made personally, like outright me saying that, oh, this needs a text search. Elasticsearch is good here. Let's go for Elasticsearch. It needs fault tolerance. Let's keep 3 replicas. Let's use 2 regions. Are you mad? This makes no sense. And now we run text search on Postgres. It's fine.
Yeah.
For our
Yeah.
level of scale, that's totally fine. So I think, Cavalier, you made a super, super useful point for large companies, small companies, everyone. Another thing that I would say is look at the scale that you have. Your scale is not Google. You're not going to have 100 million users walk into your product out of just curiosity. They
Yeah.
have better things to do in their life. The starting people will be super focused on certain requirements. They'll let you know about it. You can build it. You can build those features later on. Don't over engineer. Keep it simple. Even in system design, it's the same thing. You mentioned a message queue. Like, why do you need a message queue? Why can't a request response thing work out? Why can't there be a
Yeah.
simple icon job instead of having a complex salary pipeline? That's it. So I have learned this the hard way, I think, recently, and thank God I'm still learning. But also, unfortunately, I'm still learning. I'm still losing money, and we are we are improving. Yeah,
Yeah, absolutely. And I think it's all about improvement, right? So you can't start on day one and say, oh, this is my perfect system design, right? And this is done.
yeah,
I'm done because this is perfect. I've used all the best practices. I've used the latest, like the cutting edge technology, and it's never, there's no room for improvement. It's not going to work like that. There's always room for
yeah,
improvement because that's how you approach system design, right? You work on the current constraints, you work on the current scale, you work on the current situation, and then you design a system keeping certain like futuristic approach in mind. So you don't want to design a system that will break next week, but at least you want to design a system that will withstand the load and the complexity at least for 1 year
yeah.
or maybe 6 months. And then you
No,
slowly
I
make progress and
yeah,
iteratively make
absolutely,
improvements.
absolutely.
Yeah,
No, I'm sorry to cut you off in between, Cavalier, but I
no
think
problem.
part of this is to blame on viewers like me. I'm not being ultra harsh to myself. I'm just being honest. I started the YouTube channel with the intent to help people move into this new thing of system design because I had seen a lot of computer programmers suffer a lot at work because they did
Yeah,
not know about software engineering principles and system design. They just knew about data structures and algorithms. Now, it is a service, it is helpful, but it is also very, let's say, naive or superficial. The starting point, it's good to start off. Yes, you can. If you're a computer programmer, it is exciting. Instead of algorithms, you're learning about these discrete systems. But the fact is, when I meet people and they say that your system design videos helped, and sometimes I have a mock interview with them, I realize that I have improved a lot. What
yeah,
I've taught is basically if you have a problem, put in a message queue here. If you want to order things, then do this. And these tools are so expensive because, of course, they cost you. Recently, what I've tried to do is I've tried to bring in the aspect of real world engineering into these systems. I've been reading white papers, which helps a lot. And hopefully, I'll again be able to improve on the videos which are already made. But yes, this is one thing that I feel like after an SD1 or SD2 position, I think you should be taking all of the videos on YouTube for system design with a pinch of salt because they are interview preparation videos.
yeah.
They are not real world videos. Interview preparation is all about, okay, I can add a Kafka queue with no cost or Elasticsearch is nothing. It'll scale, yeah. But at what cost? Who knows?
Exactly, exactly. And the content on YouTube and on any other platform is made with certain assumption, right? It doesn't know anything about the real time or the real world aspect or the context of any company, right? So trying to just look at a YouTube video and applying those concepts directly to a certain context is not a great idea. And so it's not the fault of the messenger, but it's the fault of who is trying to consume that knowledge and not thinking twice before implementing it in the real world. So I think it's still useful to watch such videos to understand the basics, to understand different ideas. But at the end, system design, there's no one truth, right? Like for one company, let's say monolith works. For other company, microservices is a great thing. For tons of companies that lie in the middle, both of them are not working great. So they want some mix and match solutions, right? And
Yeah,
it's
you had a
always like
post on
that when you
this.
talk about real world.
You made a post on this on LinkedIn, I think. Yeah, totally agree.
I think that's what, like, understanding the nuances of certain best practice or certain patterns that you have seen in some other system, and then trying to implement them without understanding the nuances is a naive thing to do. But understanding those and understanding the trade offs is what separates you from the crowd. And that's what we mean by senior engineering, right? Having the
Yes.
experience. So when you look at a senior engineer, there's a lot of knives in his back based on the experience, right? There's a ton of blood that he has lost designing systems in real world, systems that are battle tested. He's been on call, facing so many ridiculous issues that could have solved
Yeah.
differently. So this ton of experience is what makes you a senior engineer, and not just years of experience. But again, coming back to that point, for interviews, right, as I mentioned earlier, the scope is very small. You have, let's say, 45 minutes, 1 hour, right? You want to get or give as many data points about your knowledge, about your experience and your approach to the interviewer, such that it increases the chance of your clearing the interview. So that is little different. So still take that approach differently, and not as if you're designing a real world system. So both of these things are different. The knowledge will stay the same.
Yeah, it's I have recently I gave some Google interviews. I do interview from time to time to uh, stay up to date. I realize that the interview space is something where you are basically putting forward your knowledge and you're trying to demonstrate that you understand these systems. But there is a bit of a problem because what you're doing is you have basically 45 minutes to show that you can think about solutions which you've read somewhere. So what's going to happen is you have no time to test these things. You have no time to talk to a product manager. This is, if I take specifically my experience with some of the FANG companies which are out there, they were around. If I start with a simple solution, there's just not enough time. If I start with,
Yeah.
okay, let's just create a CRUD API now, that's, you fail the interview. The way to clear the interviews, even for senior software or staff engineers, I've done it. And I can tell you that it's basically around you read a ton of white papers, go through these systems, and then you quickly say that some of the most important components are going to be picked up. Okay, I'm going to use
Yeah.
this database. This is what I'm going to do. So interviews are extremely superficial, even at, let's say, the best companies out there. What I would strongly suggest, if you're doing system design for team discussions and for your own company, is to sit with your team, sit with your product manager, and really try to take the smallest possible, simplest piece of code which can be deployed, and then you see that things are working. Like you said, Cavalier, no one wants code to break the next week, but it's unlikely to happen if you put a little bit of thought into it. It's fine. The first iteration is done, and you'll be surprised how much product managers are wrong sometimes in terms of, oh, this is going to be super popular.
Yeah.
Okay,
That's
let's
that's
push
true.
the prod and we'll see. Yeah.
Absolutely. Another important point that you mentioned is when you're dealing with a team, when you're working on a real problem, I think the communication aspect is really important. And like communicating with your product manager, communicating with your business stakeholders. And it boils down to the first point that you mentioned, that asking questions about like why we are doing this, the context behind certain system, and not just, okay, this is the problem, let me draw some boxes, and okay, here's the load balancer, here's the API gateway. That's not the real world approach, right? For the real world, you want to understand the context, like why we are doing some certain thing. There's one quote that I read somewhere, I don't remember, but it said something like system design is a technical problem, but it's more of a business problem, right? Because you're designing system to serve a business, to serve some customers.
Yeah.
And if you don't understand the business domain, the business context behind it, then probably that system design is will be really good on paper but not for generating paper, like the green paper. uh,
That's a good one. Yeah, that's a good one.
so so yeah, understanding the context, and that's where communication plays a like a very important role. There's so many communication gaps, like product managers say or developers don't understand, because it's not just about, oh, there are two teams and they are trying to fight. It's just one team and they are pushing towards a goal and trying to build something. So focus on communication. As a senior engineer, communication start from the very beginning is what I think. When you're hearing for about a feature or about a system for the first time, that's when it starts. And you have to start asking questions, start making sure that, do I understand this? Do I know the why part of this problem? And then communicating, once you have a basic solution, communicating it with the team and convincing them or getting them on board with the idea on your design is another skill. So what is your experience when it comes to communication, let's say with senior engineers? Because when you become a senior engineer, you're
Yeah.
talking to architects, you're talking to, let's say, product managers, really senior people. So that communication also needs a change. So what are your thoughts on that?
I think, Cavalier, you have hit the nail on the head. One of the things that we talk about a lot is technical expertise, which is important. It helps build trust, and it also can give you creative or innovative solutions. But one thing that we forget is influence. Influence in company for a senior engineer is important. You are in an individual contributor role, yes, but when you're able to speak to your product manager in a way which they are comfortable in, and if you are able to speak to different teams, and they are able to constantly think with you, give you feedback, they're invested or interested in your success,
Yeah.
that really helps. Because what happens is, nearly all of us, no one can talk to a rubber duck and get design solutions or coding solutions. You can talk
Yeah.
to a rubber duck and get maybe debugging solutions, but when people trust you and they like you, there's going to be so much power concentrated in you that life gets a little easier. The workplace gets a little easier. So this is beyond the scope of software engineering, system design. This is there for a very long time. If you're going to be a senior executive in any place, it is best if you create influence. And one of the best ways to do that is just for people to trust you, have a high standard of ethics. Okay, second thing would be that test your code, make sure that whatever you're doing is also, after all, the code is speaking for you, so it shouldn't be lying.
Yeah.
It should be like, I did this, yes, the code says yes, he did this. And then of course finally you can see a high ethics, trustable person, and yeah, is constantly looking out for you. So if I'm talking to Cavalier and I like Cavalier and I really want Cavalier to succeed, then Cavalier will like me. Most likely he'll be like, oh yeah, Gaurav, yeah, that guy, I like him, he's a friend.
Hmm.
So now this generates influence. It helps everyone around. It's totally off topic compared to most of the technical things, which are much more in front of everyone's eyes, which are easily demonstrable also and easily testable. Influence is very hard to test. So you build it in the company and the company doesn't want you to go.
Yeah, that's a great point. And like most of the senior engineers or staff engineers, principal distinguished engineers that I talk to, it's not the technical excellence that, of course, they are technically excellent, but that's not
Yeah.
the key distinguishing point that I see in them. What I see is really ruthless prioritization on tasks and features and what they are working on, right? Great communication skills. So when they talk about certain idea, it's crystal clear to, no matter what the audience is, if it's a product manager, if it's a CTO, if it's a senior or a junior engineer, they speak in a way that it's crystal clear, right? So the communication and sharing the idea behind what you're talking about is really important, and not just blabbering about certain technical things. And there's
Yeah.
no one technical in the room, so no one would understand what is a load balancer. Why are you talking about a load balancer to a product manager, right? So
Yeah. Yeah.
I think the idea is to also understand the audience, like what audience you're trying to convince, what kind of depth you should go on, and not bore the audience by talking about some technical jargons. That's not the point. The point is to communicate ideas and how it converts into the business idea that everyone is eventually interested in, right? Because ultimately you might not like it, but it's at the end it's all about making money. Because whatever startup, whatever business you're working on, it wants to make money, and making money while keeping the customer happy is a really difficult problem.
It is. I think, Cavalier, you also brought in this thing that like product managers don't want to know about load balancer. The product manager takes 2 steps forward and tries to really understand the load balancer. And if
Yeah.
it is a core part of the problem, you can bring it up in the worst
Yeah.
case. But what you want to do is you want to give them the respect and you want to save their time as much as possible and tell them things that they need to know. If you tell them that, oh, we can't do this, our load balancer is not geo based. Like, what? That is not going to help him. He can give you a solution. Maybe if
Yeah.
your load balancer is not geo based, he can help you. But if you, yeah, you explained it much better than I face this every day in the startup where you have to wear multiple masks. You're talking to the sales team, you're talking a different way. You're talking to the marketing team, you're talking a different way. If I just tell them that, oh, no, this is how I talk. Now you learn my language. That's a problem. That's not going to help the company. It's not going to help them. It doesn't help build influence. Doesn't help build money. All aspects is bad. Yeah.
Yeah, yeah. And one thing you mentioned about the IC role, right? The individual contributor role. I've more often than not, I've seen people confusing IC with isolated contributor. It's not isolation. You're never working on isolation, right? You're always in a team. So communication and thinking about, so when you write code, when you design systems, also think about like other human being in your team is going to make sense out of it. So don't overcomplicate, document things properly, don't document obvious things that people are
Yes.
sometimes they do. So that is another important point, right? So IC is not about working in a dark room wearing your dev hoodie jacket and whatever and looking at a matrix like green screen. It's not like that. It's about talking to people, it's about understanding the business. And I think that is what I've seen sometimes.
There was this person who was a staff engineer at Uber when I was working, and this person needed to probably speak to more teams than any engineering manager. And also, engineering manager, the role gives you some structural, advantage speaking to people. You can get things done. You have the weight of the organization behind you when you say that this is what is necessary. While
Yeah.
for a IC role, it's a little bit like tech sales. You're going around asking problems, trying to offer them a solution, trying to onboard
Yeah.
the solution, and the impact depends a lot on how many people actually accept your solutions, or you're a cross team person.
Yeah.
So you're trying to make fundamental changes which everyone is going to get on board into. It's so hard. And without influence, I'm going on saying the same word, but basically, like you said, Cavalier, just without being able to de-isolate yourself, become an individual contributor, it's very hard. Yeah.
Yeah, yeah, it is a hard problem. And like understanding the complexity, right? So IC is like a specialist in certain domain, right? Is how I see it. So IC is a specialist, especially senior ICs. They have designed some system, they know how to do things, right? But the input to these ICs are the business context, the product domain. And then the output is definitely the technical and a system that will work, that will generate revenue, save cost. So it's not like a person who is just writing code and talking to no one, but it's more like a specialist and people are going to consult with you. And as you mentioned about trust and about creating that influence, it's really important even in getting promotions, right? If people don't trust you, if people don't get influenced in a positive way from you, I think it's really hard to get promoted. And it comes with experience, it's not just a one day job. So I see people, oh, I've cleared a fang interview, someone must be a great engineer. Okay, that's true, but it's a journey, right? It's not okay, today I'm a great engineer and I'll be like that. It's like an award you have got. It's not like that. It's about the daily small things, the daily habits that you have, how you push your changes, how you communicate, how you write code, how you test your changes. All these small things create that kind of trust and great habits and great work ethics, as you mentioned. And that's what you're collecting with the years of experience, right? So if you're following all the best practices today, but next week you forgot everything and you just write really bad code, it's not going to work. So it's a journey. Don't think that, okay, I'm a senior now, so it's all done, I know stuff and I can do what I want. But it's about a journey, right?
Yeah, well, yeah. Something that I just imagined right now is a doctor from AIMS, India's best, one of the best medical institutes that India has. And then the doctor doing really well, learning everything about neuroscience, again, a really different field, and then becoming a drunkard and being like, I'm really smart. Like, that does not work.
Yeah.
It's no one cares. No one cares
Yeah.
if you are from AIMS, if you can't consistently do what you do. It's the same for the armed forces, it's the same for engineers. And like you said, it's not a certificate that, look, I work here, therefore I am ultra intelligent. Yes, it is an indicator. You should be proud. But oh, that's a totally separate discussion. There, I've seen people sacrifice, I think, needlessly to get a certificate from one of those companies that I get to work here.
Yeah, that's unfortunate, but that's reality in some cases. But people try
Yes,
to
yes, it
understand
is.
it's a journey. It's the habit that you collect along the way, and you have to do it continuously over years to become a great senior engineer. And people talk about 10x and 20x engineers. That's what they're talking about, right? It's not someone is writing 10 lines of code and someone else is doing like 100 lines of code. It's a 10x. It doesn't matter, right? If the 100 lines are not going to create the equivalent business impact, it's not going to matter how many lines of code you write or how many systems you design. Great. Coming back to the senior engineering, like the system design focused discussion, the complexity of the problem, as we mentioned, it also changes. The scope is one thing, like what all is covered, but how complex certain things are, right? So, how should one, in your experience, how should one deal with complexity? And what kind of strategies do people use when they become a senior engineer versus a junior engineer?
When we're talking about a junior engineer, I'm not making him look like a simpleton. I'm basically saying that their tech experience and their, let's say, their tool set when dealing with problems is not diverse.
Yeah.
They have a few things that they know. A senior engineer is expected to deal with complexity and live with complexity, live with uncertainty also to some extent. For example, if you have a problem in, let's say, that you have very little tracing in your system.
Yeah.
So right now, what's happening is every time there's an error which is reported, you have to log into some other system. Then it takes about 5 minutes for you to find that log,
Yeah.
and then to debug it is of course another challenge. So the senior engineer is probably going to hit this first. Okay, it doesn't look sexy. It's
Hmm.
not rocket science. It's not okay. Let's add another system or some
Yeah.
encoding has to be done. It's just basic thing. Now the business impact is high. So what happens with them is they're able to prioritize and tackle problems quickly. If we look at this in the context of a business, if
Mm.
you employ a senior engineer, the expectation is they'll be able to perform quickly. They'll be able to deal with complexities because they have dealt with earlier also,
Yeah.
or they're able to extend their knowledge and deal with it. And if there is some uncertainty, right, or in terms, if there is some poorly written code or design, they don't lose their heads. They're
Mm.
okay with it. This is life. This is what I'm going to deal with for the next 6 months. I think having a kid really helps. You There's this thing
Yeah.
that, oh, I really don't have a choice here. Okay, this is what's going to go on now.
Yeah.
So if you are in a new system, most likely your first reaction is, as a young engineer, is aversion or, oh my God, who's done this? This is somebody else's problem that I'm now going to fix. As for a senior engineer, no, it's my problem.
Yeah.
There's going to be complexity, that's okay. There's going to be uncertainty. I may not know the system value, that's okay. And to behave in a way that everyone else is a little more calm and a little more structured is a start of senior
Yeah.
engineering. After that, of course, yes, you are more skilled. So there is an expectation that you will be able to simplify the complexities and also find solutions quickly. For example, if you have a system which constantly is backfilling, and maybe you're able to change the entire structure so that you have to fill data on once.
Mm.
So yeah, this would be a very abstract way to put it, but yeah, if I'm seeing a senior engineer and they have a lot of complexity to deal with, they are probably going to be comfortable with the complexity, comfortable with the uncertainty, and finally propose solutions when they understand it well.
Yeah. That makes sense. In my personal experience, as and when you become senior and more senior, the complexity increases, of course, of certain things. The ambiguity also increases, right? Like you're not sure if you have a clear input. There might be a very fuzzy thing going on. You're not sure if this is always going to be true. There are certain edge cases that are going to increase, and that all creates the complexity, right? Sometimes the complexity is only in our heads, and that is very common, right? And that's the reason we try to overcomplicate stuff. Oh, if what happens if this happens, right? And maybe that's just illusion, it's not really going to happen. So try to, in my experience, what I've seen useful is try to understand in real world what are the use cases, what are the query patterns, what is the scale you're looking at, what is the peak traffic, and all these kind of metrics. And then try to understand what complexity you're imagining, is it really possible. If it's highly unlikely and it's not really risky, then probably you don't have to prioritize that, and avoid that over complexity, right? So understanding the effort required and the risk attached if certain thing is not done, I think that creates a great balance between keeping the problem space less complex while hitting like a good spot of features where you're solving all the problems that a customer wants to solve. So having that balance, like, it's really important. And what I've seen is having data points and metrics and all these things and understanding from that really helps solidify that approach.
In fact, Cavalier, now that you mention it, sometimes the complexity is either going to stay, and sometimes the problem also goes away
Yeah.
just by waiting. So if it is super complex, and like you said, if it's low on priority, the impact is not a lot, it's okay. We don't need to get to it right now. There are times when, so if, as a senior engineer, if you're speaking with the product manager, they can sometimes tell you if something is volatile also. Oh, we need this feature for the next 2 months. So then, okay, I can write code, I can design in the way I like, because this is probably not going to stay, or it's an experiment and I'll get more time to improve on it later. So there's this term, I think we captured all of it, which is VUCA:
Yeah.
volatility, uncertainty, complexity, ambiguity. And a senior engineer is expected to navigate their way through this. Entrepreneurs are expected to navigate through this all the time. But as you get more senior, of course, you're close to the business. So
Yeah.
it's good to think in these terms. Yeah.
That's a great acronym. It talks about all the negative things that might happen to you. But a senior engineer, an experienced engineer, would thrive in all that negativity, right? And all that chaos. And that's what is required.
Yeah. As
Yeah.
you paid more for it, so it's okay.
Yeah. The other important point I think we discussed a little bit here and there is decision making, right? Okay, anyone can make a decision and anyone can convince that, okay, this is the best decision. But again, it has a context and then it has an impact. So, whatever decision you're making, understanding the impact of that decision is really important. And understanding of not taking that decision is also important. To give you an example, I was working at a company where I've always been on the Java stack. So there's always this memory and allocation problems that I've seen. So there was an application that was running, and the memory was spiking, and it appeared that, oh, there is a memory leak here, right? And we got paged a couple of times because of really strict alerting rules and all that. We were discussing as a team, and I pushed for an idea that, you know what, we should take a heap dump, try to analyze the memory, and figure out the memory leak and fix it right away, because it looks like a serious concern. There was a senior engineer who said, okay, but what is the impact? What if this machine goes down because of the memory issues? And I was like, not really, because there's the other machine will come up. And okay, what is the impact if that machine doesn't come up? Okay, there will be downtime, but you know what, it's not really impacting the customer. And this, he said, you know what, I agree, I understand your motivation to work on taking a heap dump, understanding it and fixing that memory leak. I like your motivation, but I think the simplest solution is just to avoid this as much as we can, because the machine restarts. We deploy twice a week, and the memory, the accumulation that you see is happening like over a month, and we don't really have this problem. So it appears as a problem, but it's not really a problem. And distinguishing those things and taking the decision that is really pragmatic is really helpful, right? And it's not like we are sitting idle and we are not doing anything. We have a ton of features to ship. And that's when we prioritize those as compared to this memory leak, which is not really a problem. So, decision making is another really important point, and there's different types of decision you can take. So, what are your thoughts on that?
That's a great example, firstly. And It reminded me of something that I have faced very recently. We were not able to serve invoices at interview ready. If a person was purchasing the course, it
Yeah.
would take, the invoice was either being generated incorrectly or it was just not being served. Many ideas came up, and I started thinking about, okay, how do we move this code away from a lambda function again for
Yeah.
invoice generation? So into a monolith. And then I thought about, wait, what is exactly an invoice? It's a PDF file. So can we do this manually? Yes, let's do it. Yeah, that's it. That's all the that's all the code bug, because PDFs are notoriously hard to generate, and then, like you said, there's a spike in memory during that time. I don't want to know about it. I just want a PDF file. I can do that on my local
Yeah.
computer. Give it to me, I'll do it. And in a day, maybe you get one request. So we have someone who can help out. So that is not, of course, as good a decision that your senior manager made, because they still had an automated solution. But one another example of decision making helping would be, we were working this was again back in Uber, and my engineering manager was saying that this I have spent about 4 or 5 months of work on trying to fix a system which doesn't need to be fixed. Like, we are, just like you said, 4 or 5 months trying to fix a system because it seemed like the core of the system, but as we spoke to more and more customers, we realized that's not the core. Giving analytics
Yeah.
may not be the most important thing. There might be something else. So it costs so much. It costs, you hire people, you get them over there, and then you realize that this is not it for it's crazy.
Yeah.
But for him to make that decision was very brave also, because it immediately that you have made a big mistake.
It is a brave decision at times, that there's risk involved, right? And that bravery or that confidence will come with experience, because it's not a blind confidence that, oh, do it, it's not going to impact any. It's not like that. There must be some backing evidence, some data points that is helping you to make that decision. So another great point about being a senior engineer is that you're not just throwing ideas without having any backing evidence or data points, and those backing data points are going to help you convince others, right? So if you're just like not giving any concrete thought on certain things and you're just throwing ideas, people will eventually know that, okay, you know what, this is like a very shallow statement, but there's no point in understanding this or even trusting this person, because it's just a random idea. So I think that also helps to make those decisions, and eventually you will become more confident on the decisions you're making.
The more decisions you make, I think the more mistakes you end up gathering, and you realize that,
Yeah.
oh, quick decisions are not necessarily good. It's a part of, I think, growth. Yeah.
Yeah. And then the other point I recollected is, so when you're making a decision, it might have a huge impact. But then as a senior engineer, I think it's your job to reduce the blast radius. So even if things go wrong, not according to your plan, how do you reduce the impact? How do you minimize the impact? Or how do you reduce the time to bring your service back to normal? And that's all these things which are not given to you by a product manager or by business people. These are like hidden responsibilities and duties you have as a senior engineer. Handling the failures gracefully and making sure your system is resilient and consistent, and all these non-functional requirements that might not be conveyed to you by anyone, but it is really critical to have.
Yes, especially when you become more and more senior, there is an expectation that you will start doing miracles. So what happens is, if there is a some sort of ambiguity in the requirement, now it's the senior engineer's responsibility to figure it out. So what they do is, they create a small POC kind of thing, or they'll work with a teammate. Often they are closely in good terms with their manager, the engineering manager nearby. So what ends up happening is the engineering manager respects them a lot and then says, okay, fine, you need this other person. Okay, we can do something around that. You need to talk to another person. I can try to figure out how things are happening. Now, so what they do is they take the requirements, and it's not always that you can gather all the requirements together. Sometimes, frankly speaking, even the product manager doesn't know. So if you have a large team or if you have a large company, they know that it is possible, but they don't exactly know how it is possible. On the tech side, of course, it's not there. problem also. So you have to figure out where you're going to get the data from, how you're going to set something up. And like we were talking about, the problem is there is uncertainty. Like, how long will it take for me to set up a data pipeline? Yeah, who knows? It
Yeah.
could be 3 days. It could be that the other team is not going to allow me to do this. Or they will say, okay, I'll write a API for you. And that could take a week. Is something that is really challenging. And when you're making decisions, often there are some principles which help guide you make the right decisions. It's similar to software engineering. You have keep it simple, stupid, and uh, don't repeat yourself. And basically, don't repeat yourself. For a senior engineer, will be something like, if there's a tool which does it, don't do it again.
Yeah.
Yeah, if there's some open source code which I can use, again, that's another topic. Can you just take the open source code and plot to do yours? That's another problem. But those are the kind of problems that you have dealt with earlier, so you can
Yeah.
answer them correctly. Yeah. Can I use a tool? Is that okay? These are things that you have in mind.
Absolutely.
If you are looking to make a decision as a senior engineer, what I would strongly suggest is, again, make the decisions based on the requirements by consulting with your team, and have the backing of folks around you. Like, if your engineering manager is with you, it's good. Trust me, if things work out, everyone is praising you. If things don't work out, they should not feel inherent. They should not feel like this is this person's fault. It should be like,
Yeah.
oh, we all made a mistake.
That blameless culture is really important, and that depends the company you're working at. But as a senior engineer, you have to be really blameless, that any
Yeah,
mistake that you make, unless it's really intentional that someone tries to drop your table in production or whatever, I think everything should be blameless. The postmortem, the discussions that you're having, and it's really important. Great. I think we have covered a ton of important points here. And the most important point of being a senior engineer, it may not be directly related to like system design, but in a way it is, that you have to lead the design or the decisions you're making, and also mentor other engineers, right? So what I've seen is, when you're a junior engineer, of course there's some senior engineers in the team, and even if you make some mistakes, they are there to make sure that eventually they are corrected. But as a senior engineer, you have to lead that. There's no other senior engineer who is looking at your work and making sure you don't make mistakes. So as a senior engineer, I think it's really important to lead by example, and making sure that you are the leader, and you have made sure that whatever you're doing is safe as per your knowledge, and then you learn from it, and also create that example for others, that they could also evolve in such a way that eventually there is no one above them going to look after their work, and it's not going to be like spoon feeding, oh, you made a mistake here, please fix this, and then you're fixing it. So you have to pre analyze the problems that you might face in real world, and deal with it before you actually start implementing things. So that is another very important point. What are your thoughts on that?
yeah. You're looking to lead a team uh, on the tech side. Also, there's an expectation that you will allow some mistakes to happen. It's not going to
Yeah.
be. They cannot emulate you 100% and expect success. So you have to be a little forgiving. If you can lay out a path, it really helps. Like you said, leading by example. I personally think the best way for a senior engineer is to live what they say. Unfortunately, I have also seen some senior engineers who are very critical during code reviews, very critical during design reviews, but somehow their code and their design smells different. They are, it's very nice when they are writing code or when they are designing things. For some reason, they can argue for themselves and against everybody else. So
Yeah.
this is not impressing anybody. It's just your rhetoric, or your, let's say, even if you're good at arguing and logic, if you think you're building influence, that's not happening. And no one is going to back you up during promotion time, or even in general. So
Yeah.
the best way to deal with things is, again, if you are able to practice what you preach, everyone loves it. If you say that if a bug comes up at 2 o'clock in the night and we have to fix it, and you are there in the meeting while that is happening, I trust you. Okay,
Yeah.
you're here. And so, yeah, that is one, I think, major thing, just living what you say. Apart from that, yes, you can people mistake leadership as being too soft, I think, sometimes.
Mm.
Earlier, I think in the 90s, it was more like you shouting at the other person and the other person getting scared. Oh, look at the leader
Yeah.
over there. That's not a leader. Now it's become too much. Unfortunately, I feel like, are you okay? Yes, I'll do it for you. Yes, you focus on your growth. That's also not going to help. Be
Yeah.
assertive, be clear, set high standards. And if a person makes a mistake, let them know. You don't necessarily need to be extremely supportive. You can be a figure that they look up to. As long as you're not being mean or harsh, no one really dislikes you. Yeah, that's pretty much it. Like, as long as you're fine,
Yeah.
everyone likes you. Like,
Yeah. I think that's
my
really
my
important.
recent experience with engineering teams is there's politeness is mistaken as, I think, I don't know, like niceness and politeness sometimes comes across as you can, this is acceptable. Sometimes you have to make it clear that this is not acceptable also for
Hmm.
the benefit of the other person. So yeah.
Yeah. And again, communication skills is the important point, right? Like communicating that this is important, but not in a harsh or rude way that
Yeah.
the self-esteem of the other person goes away. It's not like
Yeah.
that.
Yeah.
But saying no in a way that it's still respectful, it's not like blaming someone, but it's still setting up the high standards for the team. And that's in a way you're mentoring junior engineers or even your peers, right? So I think that is really important. And sometimes I've seen, at least in my experience, I've also done that mistake in the past, that being a senior engineer, when someone comes to me and asks me something, I just give them the solution. Oh, I know this, you can do this, and that's done. That is okay, but it's more like a spoon feeding, right? That person is not going to learn from that, and he or she is going to come again and ask for the same problem. He's going to be stuck at the same problem. So I think it's best to ask those questions and help them find their own solutions, and instead of just spoon feeding their solution. And it also gives a spark to their curiosity, right? Oh, I didn't think of these questions, right? So maybe they would, next time when they face the same problem, they'll ask those same questions and they'll figure out the solution on their own. Even if not the solution, but at least they'll have the partial solution. Oh, this is what I've tried. This is not going to work. And this is my next problem. So how do I find the solution for that? So I think that also helps.
Yeah. Like, unfortunately, I have also met seniors or managers usually don't make these mistakes. But unfortunately, like you said, isolated contributors are people who think that they can get away with it because their impact is basically in an island. They might send a let me Google that for you link, or they might be quite rude to folks who are asking very simple questions. They think that this toughens them up, but it just destroys the other person's confidence.
Yeah.
And if they have any loyalty towards the company or the team, it just gets lost in a second. Or if you, not necessarily in a second, but it's not really helping.
Yeah. Yeah.
So I think partly when you're a senior engineer or when you're in any senior position, you are speaking for the company. So the values that you are displaying, if you say, I don't do evil, and you say, okay, but I can create this fake invoice to claim
Mm.
my shoe bill, that's not do no evil. That's the opposite of do no evil. So the organization also doesn't like you. If Amazon says that you are obsessed with the customer and then you say, screw this, the customer is too stupid to understand it, the organization doesn't like you, the
Yeah.
juniors don't like you, and you're, the worst thing is you're not doing justice to the language you're supposed to speak. At this
Yeah.
organization, we really care about our customers. You're a senior, you're speaking for the organization. But yeah, any senior engineer who's joining a position, like another thing that you can do is you can go through a set of things that the company truly believes in. Like at Infinity, we believe our content should be at the highest level. If a person has to load the page for 5-10 seconds, that's a big loss. Because
Mm.
in editing, we are trying to cut down on the number of seconds as much as possible so that the same amount of info
Yeah.
goes at the minimum amount of time. If the load
Yeah.
time is going to be 10 seconds, then you have already lost a lot of the things. So this is one principle. There may be some other principle that doubt should be solved. So, of course, a startup has very few principles. Amazon has 12. Uh, but that's the thing. Like, you're a senior, you understand, you speak for the company.
Absolutely. Great. I think, like, This topic is vast and there's so many things to talk about. We can talk about like for 10 hours and more, and still there will be
Yes,
pending things.
absolutely.
But I think we have covered good breadth and certain depth in some areas, which will help people to understand, okay, what senior engineering means when it comes to system design and working with a team. And it is going to help understand some of the things and also bust some of the myths. So thanks, Gaurav, for joining me today and sharing your experiences and thoughts with me and our viewers. For our viewers, if you haven't checked out Interview Ready, please do that, and also GKCS. And if you like this episode, please hit the like button, subscribe to the channel, and please don't forget to share it with your network. So thanks a lot, Gaurav.
Absolutely. Thank you, Emily, for making this possible. This is one of my favorite conversations ever. It's something which I look forward to thinking about and maybe even doing forward. It's wonderful speaking to you, someone who has so much experience in this field, someone who's lived through many of the things that we are talking about. Yeah, awesome. It's great to be part of this.
Awesome. Yeah. Thank you so much.